For an e-commerce electronics retailer, monthly sales volume may be consistently rising, yet net profits are steadily dropping. A high-level chart showing this discrepancy cannot explain it. The answer is buried within a massive volume of disconnected transaction records, customer logs, and text entries. In this state, these figures are simply data, raw, unprocessed facts. They only become useful when converted into information, processed data that provides meaning and supports decision-making. To bridge this gap, organizations employ the 8-step data analytics lifecycle. This is a rigorous pipeline used to systematically collect, clean, transform, and analyze facts to generate specific business insights. Solving a profit paradox requires pushing raw data through this deterministic process, where unorganized inputs are methodically refined into a clear directive. Microsoft Excel provides the unified ecosystem for this lifecycle. It serves as the primary engine for business analysis, providing capabilities far beyond those of a standard calculator. Excel enables the entire analytical workflow in one interface, from data cleaning and automated reporting to KPI tracking and ad hoc analysis. We will follow our electronics retailer through this cycle, moving from the initial investigation of revenue loss to a final strategic decision. Mastering this architecture is the necessary baseline for transforming disconnected facts into a multi-million-dollar strategy. The life cycle begins with Step 1, business understanding. Here, the analyst pinpoints the exact question to be answered. Why are profits decreasing even though sales are increasing? Once the problem is defined, Step 2 is data collection. The analyst extracts material from disparate sources, including CRM systems, ERP databases, and cloud storage. This material arrives in different formats. Structured data is neatly organized into rows and columns. Unstructured data, like emails and images, has no predefined format. Semi-structured data, like JSON, sits in the middle, possessing a partial organization without a rigid tabular layout. Before any evaluation begins, the analyst must force these diverse formats into a uniform structural reality within the spreadsheet. With the data gathered, we reach Step 3, data cleaning. Skipping this phase is the most common cause of analytical failure. The trim function is deployed here to mathematically strip out invisible extra spaces that often corrupt imported text strings and cause formula errors. Functions like proper are then used to standardize chaotic capitalization, ensuring that thousands of customer names are formatted consistently. The analyst then utilizes the Remove Duplicates tool to purge redundant transaction logs, which prevents repeated records from artificially inflating total metrics. Analysis built on uncleaned data will mathematically guarantee an incorrect business decision. Step 4 is data transformation. Clean data is often stored in isolated tables, which means the analyst must merge them, combining a sales table with a separate cost table. Excel uses lookup functions to act as relational bridges, searching for a value in one table to retrieve related figures from another. This is the syntax for VLOOKUP, which searches vertically to match an ID. However, it is restricted by its architecture. It can only search from left to right across columns. Modern alternatives like XLOOKUP and the index match combination overcome these directional limitations, allowing the analyst to retrieve data from any column relative to the search value. Data transformation is what finally connects isolated spreadsheet tabs into a unified relational story. In Step 5, exploratory data analysis, the analyst actively probes the unified grid to find trends, correlations, and outliers. Aggregate functions condense grids. Using SUMIFs, the analyst calculates total sales by isolating records matching the South region. This is narrowed further with COUNTIFs, counting transaction rows matching multiple conditions, like South and electronics. Conditional formatting is then applied to the return rate column. By highlighting values above average, the software reveals a statistical cluster of high product returns, specifically in the South. This exploration forces hidden problems to the surface, shifting the focus from passive data management to a targeted investigation of the underlying logistics. To present these findings, we reach Step 6, data visualization. The analyst transforms the highlighted data into a pivot table to summarize the findings without writing complex formulas. Linking this to a pivot chart instantly translates the summary into a bar chart, making the South region's return rates visually undeniable to stakeholders. This evidence leads to steps 7 and 8, insights and the business decision. Descriptive analytics answers what happened. Diagnostic analytics answers why. Predictive forecasts that profits will drop if return rates remain high. Finally, prescriptive analytics provides the solution: overhaul warehouse operations in the South. Through this rigorous process, raw data has been forged into a definitive business decision. We began with a high-level paradox and used the lifecycle to locate a precise logistical failure. The data analytics lifecycle ensures a structured, repeatable approach from the initial business problem to the final decision. Microsoft Excel provides the engine where this lifecycle is executed daily, serving as a unified platform for professional analysis. The core logic learned here, relational lookups, data cleaning, and aggregation, translates directly to advanced analysis using SQL, Python, and Power BI. A data analyst operates a deterministic pipeline that turns chaos into clarity, ultimately deciding the future of the business.